Hey, so hi guys, coming back. Now we're talking about coming back here. So we're talking about anything that can be measured over time. Now, thankfully, one group have actually done this last lesson when we did this experiment, even though I didn't ask them to. Singjay, your experiment, and Kurt too. Now, last lesson, when you guys did the HCl and NaOH neutralization, you guys did this experiment. What were you guys measuring, really? What was the main thing that you're supposed to be measuring? The temperature. The thing that you were measuring was the temperature changes, right? That's what you guys were measuring. Now, if the rest of the class, if we were actually want to find out how long it takes, we could completely do that. So you can find out the rate of temperature increase. How fast is the reaction heating up? Then in this case, you will have your temperature change. This is what you observed. So in this case, your temperature change divided by time, how long it takes. So for your case, Jay, what was your end temperature? Huh? Not Jay, sorry. Saint Jay, what was your final temperature? 42. All of a sudden you have an accent. What was your initial temperature? 23. So use final temperature 42, starting temperature, initial temperature 23. How long did it take? How long did it take to get to 42? Well, you guys recorded, didn't you? Didn't you guys record the temperature? A time? What? 3? Okay. Looks fast. But looks normal. I remember most of you guys were done in 3 minutes. 3 minutes. So in this case, when you actually do it this way, okay, so it's what? 19? Yeah, 19 degrees divided by 3 minutes. That looks like something like what? 6.33 degrees per minute. Okay. Roughly speaking, because it's 3 repeated. So that would have been your rate of temperature increase. Good so far? That also tells you how fast your reaction is going. Questions? So technically, that's one way of you calculating the rate of a reaction. Or this is what the definition of a rate of a reaction. Good? It's about anything that you can measure or count divided by time. So what this also means is this. When you design an experiment, for finding out the rates, what's one thing you must have? Yes? Time. Instrument-wise will be a timer, stopwatch. Okay? You need to have a stopwatch. Now, one thing about stopwatches and time, I didn't mention it with the other group earlier because I didn't think of it. Level of uncertainty of instruments. Okay, level of uncertainty of instruments. Stopwatch, some stopwatches can give you more, like 2 or 3 decimal place. Yeah, some stopwatches can go down to like 0.001 seconds. Okay, some stopwatches can do that, but in this class, okay, some can do that, but in this class, because all the stopwatches that we use, and also for all the experiments, we do time by you measuring things, by you pressing the button. So in this case, it doesn't matter how good the stopwatches is. Human reaction time is no better than 0.1 seconds. Okay? So in this case, is always 0.1 second, because human reaction time, if your experiment relies on you pressing the button to stop the reaction, plus or minus 0.1. Okay. Questions? No? Okay. Pause and
So plus minus 1 second is like the margin of error.
That's the margin of error, or that's a level of uncertainty. Thank you for asking that question. Thank you for asking that clarification. That is the level of uncertainty. That's the level of uncertainty. If it relies on you pressing the button. If, for example, in Olympic races where they either use a camera or a sensor, then of course, then it's not the human reaction time. Okay? Good so far? Actually, in Olympic sports like sprinting, they actually have a sensor on the block that the sprinters start off with. If they detect that the time the gunshot or signal start till the person leave the block is less, the difference is less than 0.1 second, that person would get disqualified. Because that person is jumping the gun, anticipating. Okay? Good so far? Okay, we're going to start talking about per factors, and then I'll have video per factor. Okay? Ooh,